Good evening and welcome everybody. This is Obi-Wan Pez for Simplex Pachinko. We are going to do some math tonight. So, as long as my allergies don't kill me first. At least I'm pretty sure that's what this is. Could just be a cold. In which case, it's very annoying. So, we have some interesting problems taken tonight from the Math AMATYC Educator, February 2018. This one is actually mine. Okay, cool. I also picked up a whole bunch from several of my colleagues who had kept them forever. All right. This is 106. Okay, suppose that the set P plus 2, and P plus 4 are consecutive, odd, positive, odd integers. And all are prime. Okay, so in this case, this is going to be a triplet prime. Right, these are going to be triplet primes. So just as a matter of, like, we know that some exist, right? We've got 3, 5, and 7. Okay. That might just be it. So I'm thinking that we need to look at the modulus of each of these things. So if P is prime, right, we need to say like P mod any particular number for all n, which are going to be less than or equal to the square root of that number. If we just want to think about, like, all we have to do is consider the the smaller ones. No, we should also consider the other ones. Strictly less than P over 2 because P is odd, so right, the largest number we're going to have to search is going to be if this is a multiple of 3, and whatever that's going to be. Okay. Get rid of that. So it's less than or equal to p over 3. Alright, it has to be evenly divisible by all integers. Well, no, I mean if it's prime it can't be. Right, it can't be evenly divisible by any particular values greater than p over 3. Okay, so p mod n needs to be not 0. Right. So these are going to be positive integers. So in that particular case, right, if we have p mod 3, for example, right, if we have that equal to 1 or p mod 3 is equal to 2, then, yeah, I think this has to do with cycles. This is going to imply p plus 2 mod 3 right, is going to be 0. So this fails the condition, because then that particular... This particular thing is going to be divisible by 3, so we don't want that. Right? If p mod 3 is has a modulus of 2 mod 3, then that's going to imply that p plus 2 will have, right, 2 plus 2 is 4, which is p plus 2 mod 3 is going to be equivalent to 1, which works, but then p plus 4 mod 3 is going to be equivalent to 0. So the only way that this is going to work, okay, so what we've just said is that every possible p plus 2, and p plus 4 is going to have a multiple of 3 somewhere in that set. It's either going to be p or p plus 2 or p plus 4. So the only way that this is going to work is right, if we end up having p mod 3 is equal to 0, but p is just 3 itself, right? It is prime, so therefore we can have p is 3, 5 is going to be the next odd number, and then 7 is going to be the next odd integer. Right, so then because of that, right, so because of that, we can only let in this case, one of the numbers be divisible by 3 by being 3 itself, because then that satisfies the prime number condition. Right, we can't have 1, because 1's not prime. We can't start at any other multiple of 3. Alright, so then that's going to imply that p plus 2 mod 3 is going to be 2, and then p plus 4 mod 3 is going to be 1. Alright, that's it. It's the only one that's going to work for us. So if we have the set 3, 5, 7. Okay, so next one, 107. Let x be greater than 0. And p and q are going to be real numbers. Any possible real numbers. Suppose x to the p plus 1 over x to the p is equal to 2. Find the value of x to the q plus 1 over x to the q. There is no other information. So presumably there is, for all real numbers x, there is only 2 real solutions for this. Okay, so for this, we're just gonna, man, right, this is gonna be x to the 2q when we multiply, let's not do that just yet. Alright, so this is x to the q plus 1 over x to the q is equal to just, I'm gonna guess it's n, because we want it to be an, I'm thinking they want it to be an integer, but it could be wrong. Okay. So if we were to multiply both sides by x to the q, sensation! Konnichiwa! How's it going? There's no one here? Konnichiwa? Only elided. Is that correct? I have no idea. I most certainly did not take... Alright, cool, thank you. Most certainly did not take Japanese. Or several of my friends did. And, I was the lazy bones who decided to just take French. Is that like, slightly like Chinese, where the inflection up, down, and flat will make it completely different words? So in this particular case, x to the 2q plus 1 is going to be equal to n times x to the q. Aha. Jeez. I'm dripping. I'm sure everybody needed to know. It's alright. Alright, minus n times k to the q. Plus 1 is equal to 0. Probably. I mean, I've got like a terry cloth, which may just be gross, but it's fine. It'll go in the laundry immediately. Alright, so we've done plenty of this stuff in my in my pre-calc class. We treat this as if x to the q is just a number. Yay. So let x to the q be equal to r, because why not? It's the next letter. So we get r squared minus n times r plus 1 is equal to 0. All right, and then we just treat this as if it were a quadratic. So with this particular setup, we're going to end up with r is equal to negative b is n plus or minus square root of b squared is going to be negative n squared is the same as n squared minus 4 times 1 times 1 all over 2 times 1, which is going to be n plus or minus square root of n squared minus 4 all over 2. Yay. Alright, now we want x to the q to end up getting us this stuff no matter what value we get for x. Right? So we want q to be a particular number. So x is going to then be the qth root of this thing. Okay, that's going to be interesting, maybe. We want this to work for any particular x value, but only for one particular q value. I mean, if it didn't say P and Q had to be distinct, then we could just let x to the q plus 1 over x to the q be equal to 2 as well. You know, I'm not really sure. This must have a reason to have been asked, right? This is... So I think we're supposed to assume that P and Q are two distinct real numbers. Man, I thought it was going to be like, haha, I'm so clever. I can figure this one out, but I'm not sure that it's actually doable. I could also be just making it much harder than it needs to be, which is kind of my MO, so makes sense. Alright. Let's look at this again from a slightly different perspective. So, the one that we know is x to the p plus 1 over x to the p is equal to 2, which means we have x to the 2p plus, once we shift everything back around, it's going to be the same as the other one. It's going to be minus 2 x to the p plus 1 is equal to 0. Okay, so in this particular case, this is going to be x to the... It'd be nice if it was just that, but x minus 1 x to the p minus 1 squared is equal to 0. So therefore x to the p is going to be equal to 1. So for all p in the integers, or for all p in the reals, right? X to the p plus 1 over x to the p equals 2 is just going to be 1 plus 1 equals 2. So, yeah, of course, right? But then, if we do it with the q side, we're saying that this could be just any particular number. We don't know what it is. Okay, for all q in reals then. Yeah, this question doesn't actually have enough information to solve it, but if we're going to assume, right? If we want to do this for all possible q in the reals, we're going to want one particular n value. So, I mean, I think the stuff in the inside has to be 0. In order to take any root, the qth root, and get an answer. Right? I think we're gonna have to make the inside 0. So if we do this, that's just going to be 0 there, so then n plus or minus square root n squared minus 4 is going to be equal to 0. If we bring that over, n is going to be equal to plus, that's a stupid, no, it's fine. Square root n squared minus 4. Square both sides, n squared is going to be equal to n squared minus frickin' l. Okay, so that's toast. Should have seen that coming. So 0 equals negative 4 is not going to work. So it's not that the internal portion had to be 0. It's not that. Yes, there is a more efficient way to do it. You can click select and then delete, but you know what? Erasing it's more fun. So this does not. Alright, what about the internal stuff all being 1? That may end up just leading us back to the previous answer. Alright, so n plus or minus square root n squared minus 4 is equal to 2. And if we square both sides, that's going to be terrible. So if we shift the n to the other side, that's going to be the least disgusting. Alright, plus or minus square root n squared minus 4 is equal to 2 minus n, and then square. We got n squared minus 4 is going to be equal to, oh, okay. 4. That's positive 4. That's also weird. Minus 4n plus n squared. So that's gone. And then let's shift this stuff around. So that's going to be 8 is equal to... yeah. Right, add 4. Add 4n. So 4n is equal to 8, which means that n is going to be equal to 2. And is that the exact same thing that we had up top? Yes. Right, that's the only thing we had in for this one over here. Was that our n value in the polynomial was equal to 2. So I only get one solution. It is possible that there are multiple solutions and I'm just missing one. But k to the p, or k to the p, x to the p. So this is going to be some sort of number. Ugh. Let's try a different approach. Okay, so we say just hell with it. Some real number plus its inverse is going to be equal to an integer. Now that technically doesn't have to be the case, I don't think. But it's at least going to get us some sort of idea. I mean, this is exactly what I did down below. It's not going to get us anything good. This is just r squared minus nr plus 1 is equal to 0. So, under what conditions do we get real solutions? Let's just, strip away all the unnecessary details. Under what conditions do we get real solutions? Never mind all the rest of this stuff. So with this is going to get our n plus or minus the square root of n squared minus 4 all over 2 is equal to r. So r has to be these things. That's less interesting. What we really care about is like, what is n going to be? No. Ah, okay. Yeah. N squared minus 4 needs to be greater than or equal to 0 in the first place. So n squared is greater than or equal to 4. Which means that n needs to be negative infinity to negative 2 inclusive union 2 to infinity. So n just needs to be bigger numbers or the same values as 2, whatever that's going to be. We can exclude all the negatives because, we can exclude all the negatives because we said that our x from back here is going to be a positive value, and raising positive values to any power is still going to get us positive numbers, right? So n, whatever it's going to be, has to be a positive value. We'd like it to be integers, but So here, it'll be a positive number anytime we get 2 or greater. 2 exactly gets us this stuff that we have back here. X to the p plus 1 over x to the p is 2. And then that said that here, for all possible exponents, x would have to be 1. Right, that implies x is going to be 1. Okay. Then we say, if it's not 2, what else could it be to get an integer? So how do we get whole number values for n? So, like, am I just being obtuse here? If we just say, okay, if we wanted whole numbers, let's say n was 3, this would be 9 minus 4 is 5, all over 2, so like 3 plus or minus square root of 5 over 2. If we wanted n to be 4, then it's 4 plus or minus, I mean, this is not what? Square root 12 over 2. Is this saying that we want... Again, the original question doesn't have enough information. But I'm assuming that means that here we also want n squared minus 4 to be equal to some other integer squared. So it comes out to be a nice, like, whole number. I mean, 0 is the only one, really. But we don't want that because we want positive numbers. Grr. N squared minus k squared is therefore going to be 4. So n plus k and minus k needs to be 4. So if that's true, it needs to divide 4. Both of those terms need to divide 4. Four is only divisible by 0. Lol. That's not true. Right, 1, 2, and 4. It's like they could both be 2 if n is 2 and k is 0. Can it be 1? if n is 3 and k is 1, but well, that's not true, going back to this stuff. So I think our answer is just no. I don't know. We're losing a thread here. This is not working out too well. What are the differences between squares? Right? 0, 1, 4, 9, 16. Right, our difference here is 5. Difference here is 3. Difference here is 4. Yeah, man, I don't know. I keep coming back to n is 2, and that's the only answer. So it seems like I just don't have the correct amount of information for this question. All right, 108. Find positive values of x. Such that nope, that's there exist. I know my notation, I swear. Such that f of x equals x to the x to the x has a horizontal tangent line. Okay, so a horizontal tangent line is going to be that f prime at x is equal to 0 for some particular x value. So f prime at c okay, now famously, we have a bit of a problem with tower functions. Namely, that tower functions are difficult to find their derivatives. So we have to go with ln y, as long as, y equals x to the x to the x. ln y is going to be the natural log of x to the x to the x, which is going to be x to the x times natural log of y, or natural log of x. And we're going to have to do that again. Okay, which is going to be equal to natural log of x to the x plus natural log of the natural log of x. Make that as painless as humanly possible. Right. Alright, so that one's going to be x natural log x plus natural log of x. Cool. Alright, so then we need to derive this. Alright, so d dx of natural log of the natural log of y is going to be equal to d dx of x natural log x plus natural log of the natural log of x. So when we take the derivative of a natural log, this is going to be 1 over whatever's on the inside, which is the natural log of y. Same thing's going to happen on the x side, but we'll get to it. Multiplied by the derivative of the inside of that thing, which is going to be 1 over y. And times the derivative of the thing on the inside of that, which is dy dx. Is equal to. Here we have the product rule. So the derivative of x is just 1 times natural log of x plus x times the derivative of the natural log is 1 over x, so we just get 1. Plus. Same exact thing, but this is going to be with x as a variable, so the natural log of x times 1 over x times then dx dx, which is just 1. Okay, then we need to solve for dy dx. So dy dx is equal to, we multiply both sides by y natural log of y. Whoa. Times that whole thing. So this is natural log x plus 1 plus 1 over x natural log x. Alright, and then y is again x to the x, and natural log of y is x to the x times natural log x times natural log x plus 1 over x natural log x. Well, that's pretty gross. Set equal to 0. So where is this whole thing going to be equal to 0? Okay, now I think we set up top that x can't be 0, right? Yeah, it's going to be positive. So, either Alright, all this stuff is positive. Because if we add 1, then, well, no, actually it doesn't, no, never mind. Right, x could be a small number. In theory, alright, x could be a small number. We could end up with something. Let's use natural log of x is just going to be u. This is not going to work very well. Alright, and then let's multiply by our x natural log x all the way through. So this is going to be 0 is equal to, this is going to be u squared times e to the u plus x natural log x is u e to the u plus 1. Oh boy. That's not going to be terribly convenient. Okay. It's not really helping. So if we just drop this part. Zero is going to be equal to x times natural log of x parentheses squared plus x natural log x plus 1. Or if we just left it the other way around, right? Could have been like x natural log x times natural log x plus 1 plus 1 is equal to 0. So all that stuff would have to be equal to -1. So product of a bunch of stuff. And it said, wait. Yeah, okay. Any real number. Can we find any real number such that all that stuff ends up working? Okay. So let's go to Desmos, because this is probably the only way we're going to figure this out at this point. Right? We can't get a particular nice value. So y equals -1. And then also y equals x natural log x times natural log x plus 1. What are you doing? Ugh. Fine. I just didn't know what was being multiplied. Okay, that's fair. Okay. X natural log x times natural log of x plus 1. It appears that there is no solution. So let's back this off and say, like, okay, going back up further. First of all, right, this has a solution. These other things do not, with the exception of 0 itself. No, that's not true. Alright, 0 to the 0. Okay, never mind. Those are indeterminate, so there are no solutions there. So let's see, x to the x. Oops. Yeah. Right, so x to the x has all these things. There's no 0 in the positive section, and in the negative section there's just like all sorts of disconnected values which bounce around, and we get really close to 0 but not actually 0. Oh, interesting. You add an x to the x as the exponent, and it gets approaching towards 0 again. Huh. It's not actually that value, but it begins approaching that value. And we did say that we want x's to be greater than 0 in the first place. So this is not going to get us anything. And this is not going to get us anything. Alright, this one says that the limit as x approaches 0 of x to the x to the x is going to be 0. But again, this is a limit as x is approaching 0, not actually x equals 0 itself. Or it's not at any particular value, so we can't be like, oh boy, this is what we're going to get. Like, no. It has to be what values of x greater than 0 are going to get us solutions for these. For this one, we've got e to the 0 equals our x value, so x is 1. This was... Okay, so let's take this as f of x is equal to this function, and then if we say, all right, show me f prime at x, that's going to get us our horizontal tangent value. Oh, not at 1. Well, that's a little disconcerting. Huh. Interesting. Wait a minute. No, that's not it at all. These are critical points of green. Right? How is that a critical point? It's not a critical point, right? Because we want the derivative of green. So it was where does the function x to the x to the x have critical points? It doesn't have any. This is just continuing to increase. Huh. Okay. So is this just extraneous? So it seems that x equals 1 is just an extraneous value. Why does that work? Or are we doing something wrong in the first place, which may also be true? If we're not allowed... If we're not technically allowed to take that exponent, x to the x, and treat it as one thing, is this is not associative, I don't think. Right? Because this is different. Okay, good. It's reading it the same. Because if I did this the other way, right, where I said, okay, this is going to be this stuff. This stuff raised the x. That's a different curve. Because in this case, what we're saying is that x to the x is being raised to the x power, but if you're doing that with exponents, then you could just multiply those together. So this would be x to the x squared. But that's not what we want. We want it to be a full, complete tower function. Right, so if we do f of x, that should be what we get for x to the x to the x, like that. Ah, it's not the same. Oh, that's gonna bug me. Oh no, because it's not. Okay, interesting. Give me a minute. Let me think this over. Hey, Megamorph. Sorry about that. So my spouse came in, had to say goodnight. So when we first came here a year ago, I had a full English breakfast, and I like it. It gives some savory balance to the meal and all that. Then I also get to eat my whatever my kids don't eat, so you know, it's fine. Then we also went to Wales this last vacation when they were on midterm break. And we had a full Welsh breakfast, which was basically the same as a full English, but we don't say that. Might get tossed out. And the first weekend that we were in town, our friends brought us to a place where we were eating on per diem, so it was like, let's go whole hog, man. So we did have Sunday roast with Yorkshire pudding, and yeah, it's all good stuff. And we've done fish and chips at several different locations. My spouse is a little bit wary because she's allergic to shellfish, so like it depends. If any, like, if they do any amount of prawns at all, it's like, well, can't use the fryer there. Which kind of stinks, but, you know, such is life. Such is modern life. Gotta watch out for all those allergens. Also, what are we doing? We're being wrong, is what we're doing. So this is not f of x. Right, what we're trying to do is we're trying to find the critical points of this function. So I am finding that there are none. Right, where is it that this function has a horizontal tangent was the actual question. Where'd it go? It's on the other one. This. Find all positive x values such that f of x is equal to x to the x to the x has a horizontal tangent line. So I'm finding none. They do, I guess, more by the seaside. So like we're not in Scarborough or like, you know, Wales or way on the coast, but so some places do fried prawns, but otherwise, yeah, she also just doesn't chance it for a lot of these. She's like, let's not. So I was doing logarithmic differentiation for y equals x to the x to the x, and I found that, right, we take the natural log of both sides. That's going to knock this down, but we're still going to have one extra. X to the x, there. One extra x to the x, and so we have to take the log of everything again before we differentiate it, and then it creates this long string of log differentiation. Gotta use chain rule multiple times. And then when we get back to the original, it's our original function, x to the x to the x, times the log of that thing, x to the x natural log of x, times the derivative of the x side, which ended up being natural log of x plus 1, plus 1 over x natural log x. All right, fair enough. Well, either way, I guess, right? So I ended up with an extraneous value here of this natural log of x could be 0, where x is equal to 1, but like, no. Like, that's where we get, no, it's not even an inflection point. Is that the inflection point? Maybe? Nah, not even. So, I'm kind of curious about, like, how this thing gets here. But anyway, then we said, so we're going to just go through the product. Why can't I think of this? Zero product property. Say, okay, if 0 is equal to the product of all this stuff, then one of them has to be 0. So we just set them all to 0 individually. And again, the first one and second one can't be 0. Natural log of x could be 0. Or this big long thing could be 0. And then when we knock that out, we end up with this, like, -1 equals all this stuff. Which, when I plugged it in, it's just nowhere near it. Like, it was way off. So it says, what was it? X natural log x times natural log of x plus 1. Right, and we wanted to know when does this thing equal to 1, or in other words, when does plus 1 of that equal 0? And it doesn't. So, I mean, it makes sense from the original, right? There's no 0 to this function, or there is no horizontal tangent to this function. Right? The only critical point is technically at 0 itself. Where we get a vertical tangent, looks like here, of our derivative function. So, like, I was looking at this, I'm like, oh, look, here's the answer. No, that's not what I was looking for at all. Yeah, I'm kind of curious how Desmos calculated that. Like, it's not just a limit, because it's not just open. It's a solid circle at 0, 0. So, like, it seems like it's not indeterminate, but 0 to the 0 is indeterminate. Or maybe this one isn't either. No, okay, never mind. Probably is indeterminate then. Anyway, well, that's not exactly. Never mind. That wasn't the right thing. Okay. Our derivative still has a vertical tangent at x equals 0. It's just weird. Yeah. So I was also worried with this. Like, is this but it's not associative. Was the other thing that I had. But, well, okay, it doesn't need to be associative. Never mind. I'm fine, I promise. Okay. Yeah. Alright, that makes sense. Thank you. Okay, so... yeah. Right, because I was like, well, that just makes it x to the 2x there, right? Well, see, you gotta go to some channel and get yourself a gift sub, and then you can go and do all sorts of cool stuff. That's not actually true. That one, I have actually subbed to that one. Yep, assume spherical cow. Anyway, yeah. So, at any rate, this has no horizontal tangent, so we'll just... Alright, that particular one is extraneous. So x equals 1 doesn't get us a horizontal tangent. It fails. Quite the value judgment. Man, we're really striking out on these. Kugelblitz. Okay, so 109. Interesting. They messed up their heading on this one, and it actually doesn't say, as the other ones are, proposed by. This one's just starts with the question right in the bold type. All right, duels in Raytown. Are rarely fatal. In Raytown, each contestant comes at a random moment between 5 a.m. and 6 a.m. And stays for 5 minutes. If an opponent arrives within that interval, they duel. What fraction of duels will lead to violence? Right, so person is going to arrive. Right, this is 5 a.m. to 6 a.m. It will leave at 5:05 or through to 6:05, depending on when they arrive. Or rather, the arrows go the other way. So their opponent is doing the exact same thing. So, without loss of generality, we would just say like one person is always going to arrive at arrive at 5, and then stay to 505, and then what percentage of duels will the opponent also arrive at the same time? I don't know. Does that sound reasonable? Maybe not. I don't know. So if the opponent arrives at 5, 501, 502, 503, boy. 504, or technically right on the money of 505, right? Right, because if they're like this, right, and this person is also like that, then they would actually meet at 505 if that's right. No. This is the magazine Math AMATYC Educator, and this particular one comes from the February 2018 edition. So they're 6 years old. I mean, I guess technically it might be. In theory, this and the solution could be online somewhere. So there are exactly 60 minutes in an hour, right? And then we have to consider the opposite end, because that's going to be an edge case. Right? If they arrive at 555, 556, 557, 558, 559, or exactly 6. Is that going to be any different? And then if it's random, do they really arrive exactly at 6? Is that even possible? You know, do whatever. I don't even... Okay. Oh, maybe. No, yep, that's just like the last. Yeah. Yep, that's the last page. So it only talks about the author. Oh well. Yep. Yep. So you do have to you do have to sign up for an AMATYC who's its membership in order to actually have access to this stuff. So, oh well. Oh, speaking of which, I probably need to either cancel that or update my address. I wonder if my old job has been getting my AMATYC magazine thingies. I suppose I could definitely illegally upload this onto Discord. I'm uploading it on Penn Center's Discord, so anybody who is interested, and in the oops, in the math forum section. I was talking about sensation earlier. I'm pretty sure it's just allergies, but it could also be a cold. So, hooray! Either way, feeling like I got flattened by a truck. So yeah. All right. Oh, not that one. That one. The next question, right? Is it is it a continuous thing where somebody just shows up and then goes 5 minutes, and it's like, you know, at 5 o'clock and 36.2 seconds. We're saying that, like, from 5 to 6, right, somebody's just going to show up for 5 minutes. And we want to know what's the probability that somebody else's time is going to overlap it by any amount. Like, is there some sort of probability distribution function which shows the potential for overlapping, right? Glacy Sursa. Good evening and welcome. My name is Obi-Wan Pez. This is Ensimplex Pachinko. We do all sorts of math questions and answers and like homework help and whatever you really feel like. So I'm not doing something deathly important. So if you do have a question, feel free to drop it in chat and I will answer it when we get there. What fraction of the area of the square yeah. So you're saying like 60 by 60. You have some 5-minute period over here, so you're saying let's draw that. And we have some 5-minute period over here. Wait. No, that's not going to work because it's always 5 by 5. That's not what you meant. Okay, yeah. So right now I'm working on a problem that comes from Math AMATYC Educator February 2018 edition. Basically, if you are not a math teacher, you don't have a copy of this, and we're signed up to the professional organization in 2018. But I did throw a copy of it, a just picture of that one, of that one page at Penn Center's Discord under the Math Forum section. So you can see all the problems that we worked on today. 106, 107, 108, 109 is this one, and we'll possibly do 110. All right, we've also got a whole bunch where there are also solutions that are on the page, so you know that's helpful too. So I'm going to attempt to not look at the answers for all these. Yep, no worries. We'll see how things go. And if I'm getting too tired out of it, whatever, we will probably raid over to somebody else who's doing math. I know Dawn is currently doing math, as is in his name. He has been on for 2 hours and 8 minutes, so there's a good chance he's going to stay on. All right, Megalomorph. So the y equals x plus 5 to x minus 5, and we want that everywhere between x equals 0 to 60, essentially, right? So are we just taking the... That can't be quite right. So we're saying essentially like this. And wherever we get for 60 by 60 completely to scale, I promise you 100%. Okay, yeah, okay. Draw a square 60 by 60, and then we only want this area here. Right, this is a 55 by 55 isosceles right triangle, and similarly on this side then, that should be also a 55 by 55. So in theory, right, this is going to be a 60 squared minus, two 55 by 55 triangles, which just gets us 55 squared. So then that's going to be 3600 minus, this is going to be 2500 plus another 503,025. So 500 and 275. Wow. Out of 3,600. Yeah, well. Right, so 575 out of 3600, which is then going to simplify down so we can take 25 out of everything. Alright. That's a 20. Three. Oi. Fine. No. No, wait. Hang on. Did I... Alright, we may be quitting earlier than I thought. We're good. Okay. Factor out 5 squared for both numbers. Yeah. Okay, that's fair. Right, so 12 plus 11, 12 minus 11. Woo! 1. And 23. Cool. Just avoid arithmetic. Yeah, it works. Alright, 25 is going to get us 100. 110 is going to be 4. And 100 is 5. 145. Cool. There we go. 23 out of 145. And it did say fraction, but you know, just for my own sake, I do want to put a percentage to that. So 15.86. That seems kind of high. I wouldn't want to be a dualist. What? 144. Oh man. Yeah, it's 100, right? I was apparently dividing 0.97, oh man. That just pushes it right over the top. Alrighty. 110. As many as I have / feel like doing / until somebody asks me a different question. Decently safe, yeah. Still not gonna duel people. As the number of duels that you engage in that will eventually come to violence, like the percentage starts approaching 1. Alright. This is going to be a quadratic function. Whose graph is a parabola. Cool. strictly quadratic. For some, there exists a k greater than 1 such that for x1, y1, x2, y2, up through xk, yk, distinct points. I know you're twitching, Megalomorph, because I'm like abusing notation here, but nonetheless. Let L sub 1, L sub 2, L sub k be tangent lines at the respective points. Prove the average value of x coordinates of all points of intersection of these k tangent lines equals the average value of the points x values. Woo! Wow. All right. Okay. So, in terms of the number of handshakes that there are, the number of x coordinates that will exist is going to be the same as the handshake problem, right? Because we're saying like when are all these things going to intersect each other? They are distinct from each other, so they're going to have a single unique intersection point with all other tangent lines. So, the handshake problem. This is one of the things about mathematics, anybody who doesn't really get it, is that it's really just a reduction of, like, all of the vast numbers of problems that could exist to, like, here's a strategy that'll probably work on this one. And, oh, this is, like I just said, this is analogous to the handshake problem. What's the handshake problem? Well, it's if you have a group of n people, how many hands would all of them shake in order to meet everybody else in the room? Right, so So like line K, L sub K has K minus 1 unique intersections. Then L sub K minus 1 has K minus 2 more unique intersections, because we've already counted the one that it intersected with L sub K. So it's going to end up just being the sum of all integers K minus 1 when we go from K equals 1 up to that K value. Never mind. Shouldn't reuse these. J equals 1 up to K, whatever K is. Which means that when we add up all of those numbers, this is just going to end up being J minus 1, J over 2. Whew. That's not J, it's K. God, man, come on. Get with it. So this is a little bit of number theory, a little bit of pre-calculus. You could even go with like combinatorics, graph theory. There's all sorts of different ways to solve it. So what we're saying is that if we have a parabola like this, and we have a whole bunch of a whole bunch of points on this thing. And then we want to draw tangent lines, which are those lines which only intersect at that particular the parabola at that particular point that's given. Alright, this one's gross because I messed up, but nonetheless, it's there. Ish. Alright, this one's going to go more or less sideways. Here. This one is going to go here. Touches at that point. And then here, this one touches at that point. You know, let's gotta extend these further so we can actually find the intersection points. So our task is to Our task is to find all of the intersection points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For these 5 lines that we have. And the idea was to then take all of their individual X and Y coordinates, which are not the same as those ones up there. Right, these, is that, yeah. This was going to be like X1, 2, 3, 4, 5. Right, this is X5, Y5. This is X1, Y1. X2, Y2. X3, Y3. X4, Y4. X5, X5, Y5 up there. Alright, now the orange ones are going to be the intersection points we get for all of this. So, you know, this one over here would be like capital X1, capital Y1. And then down here we go to capital X2, capital Y2. And we go through and we'd like label every single one of these. Or like, you know, this one here is the intersection between lines 1 and 2. So X12, Y12, something like whatever ridiculous scheme I want to do with this. It doesn't matter. The point is, we're going to end up with this many. Right, depending on how many points we're using. So in this case, this is 5. So 5 minus 1 times 5 all over 2 is going to tell us that this is 4 times 5 over 2 is 20 over 2, which is 10. So 10 points of intersection. So, Glacy, let me know if you want to go by anything else, but what level of math have you completed? Or are you taking now? Just completed A level, okay. So I am in Britain right now, but I still don't actually know the education system. So that's like the completion of essentially high school, or like the completion of the couple years after after that. I don't I definitely don't know what backhouse is. But fair enough. So Megalomorph, you're saying that translations and scalings affect tangent lines the same way they affect the graph. So we can argue without loss of generality, the function is simply y equals x squared. Yeah. Oh, yeah. Right. Oh, I see. Hmm. Okay. In the States, we do it very differently. So it's essentially by topic. And so, like, you're somebody who's just kind of going through standard high school practices are going to have usually Algebra 1 is either 8th or 9th grade, followed by geometry, then trigonometry, then trigonometry. That's not quite true. The way that I did it anyway was we had Algebra 1, geometry, Algebra 2, which was like a more intensive version of Algebra 1, which like used geometry to solve stuff. We did a lot of like conic sections and things like that. We moved on to trig, which was pre-calculus. Did a lot of both functions and trigonometry, and then calculus in my senior year. So yes, that is 5 things. I took 8th grade algebra, so I was 1 year ahead. And a lot of kids in my children's school district like when they got up to high school, they were already like 2-3 years ahead. I'm like, what are you people doing? So they were actually taking classes at my community college for high school credit. And it was like, yeah, I'm taking differential equations and I'm 18 years old or 17 years old, still in high school. I'm like, all right, have fun with that. All right, I'm gonna step out just for a sec because I'm gonna get more water and whatnot. But we'll call this one a 3-minute break, and then we'll be back fairly shortly. So, see you in a few. Be right back. This is Obi-Wan Pez for Simplex Pachinko. Stick around. shall return. Alright, we're back. So, Megalomorph's suggestion, yes, we can also say without loss of generality, right? It's just the function y equals x squared, or some transformed version thereof. Also, if we wanted to, we could also say, like, okay, it's a parabola, so it's a slightly modified version. Oops. And so the slope of any particular one of them is the derivative. It's going to be 2a times the quantity, b times x minus c. Nope, not d. Right, times the b that's on the inside. And then that's just going to be 2ab squared times x minus c. So we could still do this in general. Yes, Megalomorph's idea is going to make this way easier. And a leading coefficient of a times b squared, like, if it's on all of them, you just factor it out anyway, so it doesn't much matter. But still. I know, you're trying to be helpful. Tonight's stream is hashtag not sponsored by Dunkerton's Reserve Cider. Looks very pretty. So, our points are going to be of the form like capital X1, capital Y1, but yeah, see, that's just gonna intersection of 1 and 2. That's just gonna be a mess, isn't it? Right, so it goes from x minus x1 times here to a b squared times x1 minus c. Plus y1. So that's going to be L1. Not that. Alright, this is L1. L2 is y equals 2. B squared. Yeah, I know. x2 minus c. X minus x2 plus y2. We're saying we want location, whichever, where they end up being exactly the same as each other. So y2 minus y1 is equal to... I know, I'm just doing it the hard way, it's fine. 2ab squared ow. Yeah, that's fine. Right. That's that one. It's gonna be x1 minus x. Nope. x1 minus c times x minus x1 minus x2 minus c x minus x2. Oh, right. Yeah. I completely forgot about that. Yes. I do that actually during my function transformations, like, big presentation at the beginning of this stuff. I completely forgot, yeah. Sorry, I wasn't paying attention to that particular thing. Yes. So if we say that this is instead just going to be a times b squared times x minus c parentheses squared, this could be reassigned. A prime or a star or something like that, whatever we feel like. Okay. Yeah, I got you now. Alright, then that's gone. I'm sorry, yes. I had entirely been doing that the entire time that I was teaching this, and then just completely forgot it just now. It's fine. Okay, so y2 minus y1. This is going to be silly, but nonetheless, I just want to try it out. x1. minus x1 squared minus cx plus cx1. Okay, minus xx2 plus plus cx plus x2 squared minus cx2. Alright, all terms with just x in it. So we get x1 minus c plus c minus x2. Then minus x1 squared plus x2 squared plus cx1 minus cx2. Might as well. Y2 minus y1 over 2a is equal to. And here we've got x times all that. x1 minus x2 is what comes out of it. Well, that's fun. Plus c times x1 minus x2. Hey, look at that. It works. Minus x1 plus x2 times x1 minus x2, because that's the difference of squares. And wouldn't you know it, it's the exact same thing in all three places, so we can factor that out. Drop it at the bottom. This is y2 minus y1 over x1 minus x2. Curses. X2 minus x1. Turn it negative and keep the 2a out front. Equal to. Alright, in an effort not to anger the math gods, we'll keep that negative on this side here. Alright, so we got x plus c minus x1 minus x2. So our x particular value that we're looking at, this is like x12 is equal to, this is x1 plus x2 minus c minus y2 minus y1 over x2 minus x1 times 1 over 2a. This is kind of interesting to me. So this is saying, like, we're going to take the secant line that goes between these 2 points and find that slope and put it in here. Which, I mean, it makes sense, but it's just kind of like, oh, that's kind of neat how it just shows up. Absolutely. They are my ex, and why did I date them? 100%. That last song we were listening to was entitled Euclid, but for some reason they don't have the actual artist name. Okay, so without loss of generality, xmn is going to be equal to... This is probably an inappropriate use of without loss of generality as well. It's fine. Minus y2 minus y1 over x2 minus x1 times 1 over 2a. Okay. So the average of all x mn we're going to add up all So we're going to add up all of them, which is every possible combination. So this means that we end up with k minus 1 of each x sub m. This is a terrible idea. Don't do that. Of x1, k minus 1 of x sub 2, all the way up through k minus 1 of x sub k. Okay, from these things here. Because we're saying, like, if m is 1, then we have to cycle through all other n's which are not 1. So that'll be 2 through k. So k of them minus the first one. And then likewise, the one that we're not doing is the one that is m. So it's just going to shift up through the rest of the numbers. Unless that's not true. Hang on. I don't think that's true. Where's our picture? Here we go. Yeah, it's not K. Is it? Wait, hang on. How many of these are going to have x1 in it, right? Yeah. Okay, 1, 2, 3, 4. How many of them are going to have x2 in it? 1, 2, 3, 4. How many are going to have x3? 1, 2, 3, 4. Okay. But we already counted. Right. Arg. Or no, wait. Damn it. It's not k minus 1. So what's it going to be? Oh no, it is k minus 1. Right, because k in this case is 5. Right, we've got 4 x1s showing up in the calculation. Right, 1 here, 1 here, 1 here, 1 here. And then we have how many x2s showing up. It's here. I didn't count that before because that's x2, whereas we were counting x1 before. Okay. Yeah. We got it. Okay, so we can actually just go back. Oops. Yeah, I get rid of that too. Okay, so k is 5 in this case. We're adding up 4 of each of these x values that we have. I like it. In the case of x, or k equals 5. Okay, and then right, how many of those we're going to have? So there's going to be in our k equals 5 case up there, we had 10 points of intersection, so we're going to get 10 C's. In that case, that was k minus 1 times k over 2 times C. And then we're going to get all of the unique slopes. So those are all different combinations. Right? This is 1, 2, 1, 3, 1, 4, 1, 5. 2, 2, 2, 3, 2, 4. So again, this is just counting up how many points there are. But all of them are individual slopes. Ugh. Sum up. That's not going to work nicely. Sum. Y I minus y yj over xi minus xj, where they're all going from 1 to 5, right? And then it's just 0 when they overlap. No, you can't do that because the bottom's going to mess up. That's totally appropriate notation. 100%. Times 1 over 2a. Why are we doing Silent Night? Alright, minus 1 over 2a times that stuff. Okay, and then we have to divide by the number of items we have, which again was the k minus 1 times k all over 2. Okay. Which is going to be the sum of all... No, right, that's not technically 5, right? We should have that be k. This was the sum of x sub I going from 1 to k, and the x minus 1 was pulled out, but we divide by x minus 1 here, so we're still dividing by k, and then the 2 can come up top and multiply. So this is going to be 2 over k. We'll deal with that in a sec. Okay, minus. This is probably a horrible nightmare, so don't worry about it. Minus c, because those coefficients are the same. Minus. Okay, 2 over 2a k minus 1 times k times that double sum here. J goes from 1 to k, I goes from 1 to k, and they can't be the same. Of y sub I minus y sub j over x sub I minus x sub j. Alright, Glacy. If you want, again, like I said, anytime, just interrupt me. But you're welcome to come back anytime. Most of the time I do math on Tuesday nights and gaming on Friday nights, and then like whatever in between. I decided to balance stuff out this week because we've got tomorrow night is going to be, instead of me playing a game, I'm going to be watching Don Does Math, playing my favorite game, Outer Wilds. So if anybody is interested in coming on over, I do recommend that if you are ever going to check this out, if you are ever going to play Outer Wilds, don't watch it. Go into it with as little information as humanly possible. It is amazing, and I love every second of it, and it goes a complete... I will not be here tomorrow. I am gonna be at Don's channel. That's the one that I put in chat there. So I'm gonna be a mod for him, and make sure the chat stays spoiler free, which sometimes is a job unto itself. But you can also check out Don for math content, because he's actually right there right now, doing stuff that he found on Reddit, I think. So he does a lot of math tutoring type stuff in his real life job. So he also decided to, try it out on Twitch. And I was once upon a time a associate professor of mathematics at a 2-year college in Maryland, in the United States. And then I have since moved to the UK with my family and don't have another job, so I'm going to try to expand this one out, see how it goes. But at any rate, have a good night. I'll possibly see you tomorrow, and if not, some other time. I'll be around. Have a good one. Oh yeah, no problem. Okay, so this is... It's right there. It's right there. Awesome. Alright, see you next time. So, like, all this stuff needs to be equal to 1 over k sum as I goes from 1 to k of x of I, the sum of all those individual integers. Like, it needs to be that. Yeah, we got our 2's here. We're going to divide out, but that's fine. That's going to be tricky. And try to get that to line up nicely. Maybe. Maybe it's super easy and I just don't see it. Well, hang on. This is then 2k minus 1 times k over 2. So that's out 2. Yeah. Okay. We get meh. Hang on. Alright, this is k minus 1. This is 2 over k times k all over 2. So it's just equal to k minus 1. And again, alternatively, this just needs to be, right, minus 1 over k times k minus 1 times k over, this is going to be all messy. This is k minus 1 over 2, so all this is just going to be equal to k minus 1 over 2. That doesn't make any sense. Hang on. Well, oh no, hang on. No, that's a solid number. Man, that's messed up. That can't be right, right? Because we're saying it had to be just the average of all the x values that are there. Oh, no. Jeez. Hang on. These aren't integers. Man. This isn't gonna be... Alright, where did I start doing that? Because that's just wrong. Was it just down at the bottom? Yeah, it's just down at the bottom. That's cool. Alright, this is... no. Okay, so each of those things... Right, this thing right here does not translate into that. That's okay. Jeez. Alright, this stuff has to be a negative sum. I goes from 1 to k. Over k, 1 over k on the outside times sum of x sub I. Okay, so all of this stuff needs to be that. Now the question is, how do we prove it? Or how do we get that to work? So that x bar is going to just become 1 over k times the sum, as I goes from 1 to k, of x sub I. So that's what's going to happen. Now the question is, how the F do we make that happen? Or rather, show that that happens, because that is a given. Step 3 profit, or step 3 ... step 4 profit. Ugh. Do we then have to plug in all of the y sub I, y sub j's? I think that might be the case. In which case, right, it is going to basically fall to the exact same thing that Megalomorph was saying all along, which was, it's just a transformation, so therefore it doesn't matter if we like state that it's a transformation right up front. Right, this is going to be a times x minus c squared sub I there, plus d minus parentheses a times x sub j minus c squared plus d. Okay, d's automatically just go away here because we're subtracting them. And if getting a parentheses all of it, x sub I minus c parentheses squared minus x sub j minus c squared. Okay, this is if we expand it out, which again, ridiculous, but nonetheless. X sub I squared minus 2c x sub I plus c squared minus parentheses x sub j squared minus 2c x sub j yes, again, I know this is ridiculous, just humor me. Plus c squared. Yeah. Yeah. I'm just trying to be as pedantically rigorous as possible. Okay, so minus 2c parentheses. X of I minus x of j. And then we're out of c squareds because they subtract out. So that's going to get us an a times the quantity. X of I minus x of j times the quantity. X of I plus x of j minus 2c. Okay, and then we divide it by x of I minus x of j. I think, right? Was the way that was? Yep. So that's gone. Which means now this is just going to be sum. A goes outside. X of I minus plus x of j minus 2c. These all become separate. Someone tried to friend you on Facebook. When I asked where I might know them from, they replied, "Glad to hear from you. I'm doing great and enjoying the moment of feeling excited. Trying to stay healthy and safe. Save. Do you receive any notification from NSF program yet?" Possibly. Or it's a student who actually is looking to do some sort of NSF program. In which case, there is the possibility they're just trying to get your email. In which case, yeah, definitely don't send that. But you know that. I'd be extremely wary. So with the double one, oh, that's going to be really weird. So now, this is going to multiply A by the bit we had on the outside already, which was 1 over negative 1 over A k minus 1 times k. Right? Now our A's are gone. I is less than J? Does that have to be strictly? I just said that I was not equal to J. Oh, yeah, because... right. Because then it's going to overlap. Right. Okay. It's going to be half as many as this. Yep. That sounds like something else I know. I guess technically, right? We could also eliminate this bit and nope. Eliminate this bit and say that that's going to j minus 1. Already? Come on, man. Ad start in 5 minutes, man. Is that not working? Seems to have worked, allegedly. I think I'm going to probably end it, though. Within that 5 minute... Come on, now. Really? Come on, Twitch. Wake up. Oy. All right. Right, so the negative 2c gets multiplied by just the KC whatever KC2. This is a negative 1 over k minus 1 times k times the quantity. So negative 2c multiplied by kc2 is then going to be like k factorial over 2k minus 2. So yeah, it leaves k and k minus 1 up top. Right, and 2 at the bottom. Yeah. Okay, so then this is going to be the sum of all x sub I not quite. Not with the conditional piece. Damn it. How does this actually make it out? Okay, so we got... It's just the sum of all of the x sub i's and x sub j's, which are going to be all the different possibilities that we can go through and make, which are going to be the 10 possible locations. So that's going to be each individually Is that just another k minus 1? There's 4 of each. I want it to be that. That doesn't necessarily mean that notation is right. Right, so x sub 1, as long as it's less than j, x sub 2, 3, 4, and 5. 2, 3, 4, 5. Right? Sub 2 is going to get 3, 4, and 5. 4, 3, 2, 1. Yeah. Alright, again, notation's terrible. What does it get us for each of these things? Yeah. Okay. K minus 1. X of I. K minus 1. X of j. Oh, well, okay. Not quite that easy. Hang on. Each of them separately. K minus 1 times each of the x of i's for all possible i's. 1 to k. That's, again, that's what I want. That's not necessarily what's going to happen. The 2's are here. Those go away. K minus 1's all come out. That's just going to be a C if we multiply all this stuff in. This one ends up losing the K minus 1. I goes from 1 to K of X of I all over. Why is the C not canceling out? Wait. There might be another... Yeah, there might be another piece. Okay. All over K. Okay, and then we gotta copy all this stuff. So there it is. There's the minus C I forgot about. Minus C. And then 2 over K. Sum I goes from 1 to K. Wow. of x sub I. Alright. Moral of the story. Be careful how much cider you drink. Okay, x bar. Therefore is equal to I goes from 1 to k of x sub I all divided by k. Woo! This is far less of a and then a miracle happened than that comic, but nonetheless. Right, so here each one of those x sub i's and x sub j's are all going to show up k minus 1 times throughout this whole sum. So when we get that, then we could say that, okay, it's k minus 1 times the sum of each of those individual x's, regardless of what we call them. I's and j's and all that other stuff. So they eventually combine and voila, it works. Right, we had the 2 over k times the sum as I goes from 1 to k of x sub I. That was here. Minus c is here. Plus c came from this term here. Right, our parts on the bottom multiplied in times the parts on the top. Those all went away. Negative times negative is positive, positive c. And then here, a negative times a positive stuff is going to be minus that sum. And that's the same thing as the first one, only here there's 2 of them minus 1 of them. So therefore there's 1 of them left. And that's the average value of all of the points that are given. Pretty much. Alright. I think that's good. So anyway, we... Gonna go check out. Let's see. For anybody who wants to check it out, hang on. For anybody who wants to go check it out, we'll go see Danny Highway. Oh. So Danny runs math help as well as does a lot of gaming stuff. He's more of a sort of philosophical type person and enjoys doing tutoring, which is more of a like, here's what you need to get in order to functionally work inside of your math classes, than necessarily the stuff that I like to do, which is, here's the gigantic philosophy behind everything. That tends to frustrate some people, and, you know, I can't blame them. It's fine. At any rate, we're going to go see Danny, and, like I said, tomorrow we're going to go over to Dawn's channel. Dawn Does Math. And we'll go check him out and watch him do Outer Wilds. I will be a mod on that particular channel, so behave yourselves, those of you who do know some secrets. Don't spoil anything. It is a game that I highly recommend, and also don't want anybody to hear any information that might spoil something. So, hope you all have a good day. I will see you possibly tomorrow, possibly next week sometime, possibly sometime in between, so we'll see how it goes. My name is Obi-Wan Pez, this is N Simplex Pachinko. Have a good night.